everyone, welcome to our next video. This one is going to be, we're going to finish up the graphing section. So this is going to be 5.6, which is graphs of other functions. So the first thing that I want to talk about in this section is all the graphs that we're going to do in here have what we call vertical asymptotes. So in case you don't remember what an asymptote is, an asymptote is a line that is approached by your graph, but your graph never actually reaches it. So here, let me write that out for us. So a vertical asymptote is a vertical line that the graph approaches but never reaches. I'm also going to put a note here that it cannot cross either. So a graph cannot actually cross or ever really reach its vertical asymptote. And so what usually creates these vertical asymptotes is some kind of domain restriction. Some kind of domain restriction is what will create a vertical asymptote. So an example of something that has a vertical asymptote is, let's think of something. If you ever have like a rational function, so for instance, the function y equals 1 over x, what this graph looks like is like this. And it has a vertical asymptote right here at x equals 0. And it's because the denominator cannot equal 0, because then we have an undefined value. So that's what creates our vertical asymptote. Now, whenever we draw vertical asymptotes, we usually draw vertical asymptotes as a dotted line. Dotted because the graph actually never reaches it, so it's not defined on that line. Yeah. Okay, so for our first example, I want us to talk about cosecant. So we're going to look at the graph of cosecant x. Cosecant is the reciprocal of sine. So this is the same as me saying we're going to graph 1 over sine x. So since this is a rational function, we never want the denominator to equal 0. So we'll have to say that sine x cannot equal 0. So then I'm going to ask what values of x are not allowed. So if sine is not allowed to equal 0, I want to know what x values would you plug into this where like sine would equal 0, because that's what we don't want to allow. So really what I'm asking is, where does sine equal 0? So I'm going to remind you of the unit circle. I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So sine equals 0 here and here. So the angles that make that happen would be 0. So we don't want it to be 0. Pi. So we don't want it to be pi. and then also 2 pi. So we don't want x to equal 2 pi. What we are really seeing here is we're seeing the vertical asymptotes. So if I draw my cosecant graph, starting out just like a sine or cosine, so I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. These are going to be my asymptotes. So the x values that would create a 0 in the denominator, those are my asymptotes. So I'll have one at 0, pi, and 2 pi. Now let's see what happens at pi over 2 and 3 pi over 2. Y equals cosecant pi over 2 is the same as 1 over sine of pi over 2. Sine of pi over 2 is 1. I'm getting that from up here. So cosecant pi over 2 is also 1. So that would go up here at 1. 3 pi over 2 would be cosecant 3 pi over 2, which is the same as 1 over sine of 3 pi over 2. 3 pi over 2 is down here, so that's going to be negative 1. So cosecant 3 pi over 2 is also negative 1. I'll just show you what the rest of the graph looks like. You could always plug in more points though if we needed to. So if we wanted to like plug in right between here or right between here, this would be pi over 4. This between pi over 2 and pi would be 3 pi over 4, would be right between those. So if you wanted to plug those in, you could, but I'll show you what the graph looks like. It'll look something like this. They almost kind of look like parabolas, but just to be aware here, they are being bounded by that asymptote. So we are not able to go past that dotted line. I'll show you as well that the sine graph lies right in the middle of these. So here's what sine looks like. And let me redraw that because that looked kind of bad. Here, here, down, and up. So in the middle there is the sine graph. And so cosecant, what it'll have is everywhere that sine crosses the x-axis, that's where sine equals 0. So cosecant would have an asymptote there. And then everywhere that sine reached its maximums and minimums, that's where we'll actually see the graph of cosecant. And it goes the opposite way because it's the reciprocal. Let's do another example of cosecant. If maybe I did like y equals, let's do 2 cosecant x minus pi over 3, something like this. What we would first do in general when we do this is we would first graph sine of the same graph. So we graph everything the same, but we would do sine instead. So I'll let you guys do that, but I'll just draw our graph for us. So this would be pi over 3. The next point would be pi over 2 plus pi over 3, which is going to be 3 pi over 6 plus 2 pi over 6, 5 pi over 6. The next point would be pi plus, so it would be 0 plus pi over 3, pi over 3. The next point would be pi plus pi over 3, so that's going to be 4 pi over 3. My next point would be 3 pi over 2 plus pi over 3. So that's going to be 9 pi over 6 plus 2 pi over 6, or 11 pi over 6. My last point would be 2 pi plus pi over 3. So that's going to be 7 pi over 3. My amplitude is 2, so it'll go up to 2 and down to -2. There's no vertical shift, so I still go right through the middle. So here's my graph of sine. And so cosecant, I'll just do it in another color. I'll do it in purple. It would have asymptotes everywhere that sine was 0. Basically in all those like middle pieces. And it'll have parabola shapes at the max and the min. So whenever you want to graph cosecant by hand, this is what we do. We first graph sine, and then we do cosecant. Very similar idea for secant. So if you want to graph secant, secant is 1 over cosine x. So first let's find everywhere that cosine would equal 0, because that's where we are going to see asymptotes. You go back to your unit circle. Here, I'll redraw it right here for us. So cosine equals 0 here and here. So that means that we do not want x to be pi over 2, and we also don't want it to be 3 pi over 2. That's where I'm going to see asymptotes for secant. I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's do pi over 2, 3 pi over 2, and I'll plug in the other points. So if I do secant 0, be 1 over cosine of 0. Cosine of 0 is 1. If I do secant of pi, it'll be 1 over cosine pi. Cosine pi is -1. I get -1 here. And then secant of 2 pi is basically the same as 0. So this is also +1. So your graph of cosecant will look very, very similar. It just has asymptotes in a different place. And it has the like parabola-ish shapes on the other places. The idea is the same, where cosine looks like this. So it's right in the middle of that secant graph. And so what's happening here is we have asymptotes everywhere that we're in like the middle portion of cosine, where it touches that x-axis. And we have those parabola shapes at the minimum and maximums. Very similar to with cosecant, if you want to graph the graph of secant, no matter what it looks like, you would first graph cosine. So since we've already done graphs of sine and cosine, and we did a good bit of them. I'm going to leave it here. And so, again, whenever you do cosecant and secant, first you would do sine and cosine, and then you would just draw in your asymptotes and then draw those parabolas at the top and bottom. Now, of course, whenever you see this online and stuff, they're not going to have that cosine or that sine in the middle of it. It's just going to be blank there. But when you do it by hand, that would be our process. The next important graph that I want to talk about is tangent. So a little note that I want to make here. Whenever we did sine and cosine, I'm going to review a little bit. I'm going to go back. Whenever we did sine and cosine, do you remember with the x values how we kept doing like our 0, pi over 2, pi, 3 pi over 2, and 2 pi? That was because those are the original points that sine and cosine passes through to get our picture. Tangent has different points that it crosses through. So there's a few things that I would like to tell you about tangent. First, the period for tangent is a little bit different than sine and cosine. For tangent, it would be your pi over b. So that part is different. Amplitude would still be your a value. Your phase shift is still c over b. And your vertical shift is still d. It's just the period that changes, and we'll kind of see why and everything. And so first, I'm going to graph on our unit circle first. So I have 0, pi over 2, pi, 3 pi over 2. This goes to 2 pi. Okay, remember, tangent is sine over cosine or y over x. So what I want you to see here for a moment is if I do at 0 radians, if I do my tangent, so tangent of 0 would be my y over my x. So that'd be 0 over 1. So here it equals 0. If I go up to pi over 2, tangent of pi over 2 would be 1 over 0. So that's actually going to be undefined. Over by pi, if I do tangent of pi, I'm going to get 0 over negative 1, which is 0. 3 pi over 2, if I do tangent 3 pi over 2, I'm going to get negative 1 over 0, which is undefined. Okay, so a point that I would like to make to you here is that one cycle of tangent appears between two asymptotes. Asymptotes happen when for what we're talking about at least, when the denominator equals 0, so where we see undefined values. So that's going to happen up here at pi over 2 and down here at 3 pi over 2. So that is one cycle of tangent appears between my asymptotes. Okay, so here's the point that I want to make to you. Here, let me write it like this. Y equals tangent x. We are finding original values, 5 points, where one cycle appears. So for sine and cosine, it's easy to find where one cycle appears. It's 0 to 2 pi. But for tangent, it's between pi over 2 and 3 pi over 2. So my first x value here is going to be pi over 2. My last is going to be 3 pi over 2. Directly between these, I still want to find 5 points. But these are going to be my first and my last. Again, because those are where the asymptotes are. So what we're going to see for my graph is that pi over 2 and 3 pi over 2. I have asymptotes. Now I want to find the values in between. Now remember, I've told you this before, but the x values are always equally spaced. So if we look for the value right in the middle of pi over 2 and 3 pi over 2, I'm going to come up here to my unit circle. Can you think for a moment, what is directly between pi over 2 and 3 pi over 2? You can pause. The answer would be pi. Now I want to think about what is directly between pi over 2 and pi. So that's right here. What is this value directly between pi over 2 and pi? In degrees, I'm asking you what's directly between 90 and 180. In degrees, it would be 135 degrees. In radians, that point is the point 3 pi over 4. Then I'll ask you, what is directly between pi and 3 pi over 2? So on my unit circle, I'm asking, what is this angle right here? Directly between 180 and 270. In degrees, that point would be the point, or angle would be the angle 225. In radians, that angle is 5 pi over 4. Now let's talk about my y's. For my y's, I'm just going to go ahead and plug all of these into tangent. So if I do y equals tangent pi over 2, that would be 1 over 0, which is undefined. And that's why I have an asymptote there. I have to cough. I'm going to mute my mic real quick. Sorry about that. Now let's do my second one. Y equals tangent 3 pi over 4. Now 3 pi over 4 has a reference of 45 degrees. So 45 degrees, tangent is 1. But be careful. 3 pi over 4 is in quadrant 2. Only sine is positive in quadrant 2. So tangent is a negative. Next, tangent of pi. I have this one up there already on the unit circle. I already talked about it. But tangent pi would be 0 over negative 1, so that would be 0. 5 pi over 4, tangent 5 pi over 4. The reference is pi over 4, or 45 degrees, so tangent is 1. But since it's in quadrant 3, tangent is positive in quadrant 3, so it's going to be a positive 1. And lastly, tangent 3 pi over 2 is going to be negative 1 over 0, which is undefined. And we have an asymptote there, so that makes sense. So now I'm going to graph these so that I can see the picture of my graph. So I have negative 1 and 1. So if this is 3 pi over 4, pi and 5 pi over 4, I have negative 1, 0, and 1. And I'll show you what the graph looks like. It looks something like this. I may actually show you real quick on Desmos. Okay, so students can often have trouble with tangents, so I just want to talk about it a little bit further. The points are different that we use for sine and cosine versus tangent because tangent just has different original points that we see one whole cycle. So it shows one cycle between its two asymptotes. So then I found 3 points within those asymptotes that are equally spaced. That's why I have 3 pi over 4, pi, and 5 pi over 4. Then I plugged in all these values so that I could get my y's, and that way I could draw my picture. Let's go ahead and look at it on Desmos really quick. So here, don't worry about this. This is my other class's notes. I'm going to come over to Desmos, and I'm just going to graph for us tangent y equals tangent x. So here's what our graph looks like. And so what we found, here I'll go ahead and zoom in, is we're looking at the values y equals pi over 2. Oh, sorry, x equals 3 pi over 4. X equals pi. X equals 5 pi over 4. And x equals 3 pi over 2. So I know this might look a little weird to see all these different colors and stuff, but this is what we just graphed. So the blue was my asymptote, that red on the end were my asymptotes, and then my purple was my at pi, my green at pi, 3 pi over 4, and then my black at 5 pi over 4. So here's what my graph looks like. Now, I'm pretty sure for those of you who are taking this with me in the summer of 2026, but I'm leave these videos up, so I guess they can be watched whenever. If you're using Alex as your homework, I think sometimes they do their tangent graph a little bit different. That's just something you have to be kind of aware of. If they maybe graph a different cycle, so like they may do the cycle that's between negative pi over 2 and pi over 2. So what happens here is your asymptotes are just repeating themselves over and over and over again. So if you want to do the graph in between there, it would still look the same, but those points would be the point 0. This would be pi over 4, and this would be negative pi over 4. So you may see this as your work in the homework. That's kind of one way one way to work through it. That way is pretty nice because it involves quadrant 1. So I do like it. So whenever you graph this for me, so this is just another cycle. So let's say that you graph for me and on the test you do x equals negative pi over 2 and x equals pi over 2. So directly between there would be 0, and then you'd have negative pi over 4 and pi over 4. Your y values would be the exact same. Undefined, negative 1, 0, 1, undefined. So if you graph that one for me on the test, if you graph that cycle, I almost honestly like that one a little bit more now that I'm working through it with y'all, but that would be fine as well. That part, it's completely up to you, whatever you like. This one might be a little easier to remember. So again, this is just that cycle that's in red. So first I did the cycle in green. You can also do the cycle in red, whichever. Let's talk about with transformations. So if you have transformations, remember that the original, you have transformations. Your A value is your amplitude. Absolute value of your A value. Your period, let's talk about period. I already wrote this, but it would be pi over b. The reason that it's pi is because it's like half the space of sine and cosine. So if you think about it on the unit circle, I know this all looks a little messy now that I've written all over it, but for sine and cosine, you go all the way from 0 to 2 pi. But for tangent, we only go between pi over 2 and 3 pi over 2. Or if you want to think of this as negative pi over 2 to pi over 2, however you like to think about it, but it's half of the graph. So pi over b shows one cycle. Phase shift and the vertical shift would be the same values, though, as sine and cosine. So let's go ahead and do an example of tangent. So with tangent, I'm going to do 2 tangent, let's do 3x minus pi plus 1. And so I'm going to use these as my original points for a moment. I want to try these out and see how you guys react to these. Sometimes when I've done this section in previous classes, I'm still trying to figure out a way that really connects with the students. So maybe let's try using these points. Maybe it'll feel better. So when I transform my x values, I'm still going to do my period and amplitude and everything just like I did with sine and cosine. So it's amplitude, my phase shift, my vertical shift. I'm still going to label my A, B, C, and D. So period would be pi over B. So here that would be pi over 3. Amplitude is absolute value of A, so that's going to be 2. Phase shift would be C over B, so that's going to be pi over 3. Vertical shift is D, so it's going to be 1. So here I'm moving to the right. Here I'm moving up 1. For my x values, I'm going to use the parentheses and I'm going to set it equal to the original points that tangent passes through. So I'm going to use these ones that I boxed in just to see if maybe these will work better with students this quarter. So let's do equal to negative pi over 2, equal to negative pi over 4, equal to 0 equal to pi over 4 and equal to 3 pi over, pi over 2. Just like with sine and cosine, I'm going to solve for the x value, but the only thing that has changed in finding the x values is these have changed. So just be careful about that. They've changed because the original values that the graph passes through have changed. But the solving part's the same, so I'm going to add pi to both sides. You'll notice that I'm putting it as the same denominator. Then I'll divide by 3. So be careful. Dividing by 3 is the same as multiplying by 1/3. I'm going to multiply this by 1/3, multiply by 1/3, multiply by 1/3, multiply by 1/3, multiply by 1/3. Now, if you like to show a little bit more work than me, that's perfectly fine. So this would be pi over 2 times 1/3, so pi over 6. This would be 3 pi over 4 times 1/3. Here, let me show more work. I really should just show more. This would be pi over 2 times 1/3. This one would be 3 pi over 4 times 1/3. Pi times 1/3. 5 pi over 4 times 1/3. And 3 pi over 2 times 1/3. If I simplify here, I get x equals pi over 6, x equals pi over 4, x equals pi over 3, x equals 5 pi over 12, and x equals pi over 2. So these are my x values, so I'm going to plot these on my graph. They're all positive, so I can draw them all on this side. So pi over 6, pi over 4, pi over 3, 5 pi over 12, and pi over 2. You're always welcome to plug these back in, but the original y values that tangent passes through, I'm going to do the same thing I did for sine and cosine. So for my y values, I always do a, my parentheses, plus my d value. So my a value here was 2, and then my d value was plus 1. Now in these parentheses, I'm going to use the original values of tangent. So the original values of tangent for the y values, I'm using the ones right here. So I have undefined, so it's still going to be undefined, -1, 0, 1, and then undefined. My first and my last should always be undefined for tangent. Then I have -2 plus 1, so -1, 0, and 3. Now I can graph, so I have -1, 0, 1, 2, 3. My asymptotes are at the first and the last. Oh, sorry. I see a mistake that I made. You might have already noticed it, and you're like, ah, there's a mistake in there, Miss Owens. This should be a 1 right here. I don't know what I was thinking. Pi over 4, negative 1. Pi over 3, I get 1. 5 pi over 12, I get 3. It should make sense that my y values all have a difference of 2 between them because my amplitude is 2. So my graph looks something like this. That's the best I can graph it. It's just a sketch, don't worry. As long as you're not drawing me something like this, we should be all right. So that's graphing tangent. I actually really like these as the original values, so maybe I'll stick with these. I'll see how you guys do, and maybe that'll be the new way that I do these. Some things to notice from the original to our one that we just did. I had a vertical shift of 1 in the middle of my graph. Oh, I didn't mean to erase that. The middle of my graph is right through 1. I have an amplitude of 2, so I have a space here of 2, and I have a space here of 2. So that all checks out. X values, it's a little harder to like check it per se. Oh, I went all the way to the top, y'all. X values is a little harder to check, but some things you can look for is if you take your last X value minus your first X value, it should equal your period. Now the phase shift, it's hard to check something like that. If you use these points, then the phase shift will end up as the middle. So like your third point. Okay. Let's do cotangent. So y equals cotangent. Oh, something else I want to mention. On the test, sometimes I will ask for you to write out your asymptotes. And so just a reminder, your asymptotes are wherever you have these vertical lines, wherever you had a y value that was undefined. So that happened at x equals 6 and x equals pi over 2. Another way you can write your asymptotes is we can say pi over 6 plus pi over 3 times k. This is a notation to say that I can write all of my asymptotes this way, because every time I add a period to an asymptote, I'm going to find another asymptote. So that's going to be where another cycle lies. Now let's do cotangent. So cotangent, I'll do this one a little quicker. So cotangent has the original values of its cosine over sine. So tangent is sine over cosine. Cotangent is cosine over sine. So when I look at my unit circle, cotangent is going to be undefined here and here, everywhere that sine is equal to 0. So what we're going to see for cotangent is that my first asymptote is going to be at 0. So my first point is going to be at 0. And my next asymptote is going to be at pi. Directly between these is pi over 2. Directly between 0 and pi over 2 is pi over 4. Directly between pi over 2 and pi is 3 pi over 4. The original y values, we are undefined at 0 and pi. Cotangent pi over 4 is positive 1. Cotangent pi over 2 is 0. Cotangent 3 pi over 4 is negative 1. So these are your original values for cotangent. Here's what the graph looks like. It looks very, very similar. But your asymptotes are at slightly different places. And the graph is actually flipped. So it goes this way instead. So that's the graph of cotangent. Now, if you wanted to do cotangent with some transformations, the only things that would change is you would still use the same process, but when you do your x values, you would set your parentheses equal to these values. And when you do your y values, in your parentheses, you'll plug in these values. So the process is all the same. The only thing that would change is the actual numbers that you're using as those original points. So that'll be it for our video today, and I will see y'all in the next one. I hope you're having a wonderful day. Yeah, I'm just thinking if there's anything else I need to say, but I think that's all. Hope y'all have a good day. Bye-bye.